makinig na ng maigi. Okay. So, let's begin. We are now in chapter 3, and this is chemical equilibrium. Okay. For STEM students, this is not new. Okay. Sa mga STEM student dyan, hindi ito bago kasi this is Gen Chem 2. Okay. So basically, yung diniscuss ng Gen Chem 2, ito pa rin yun. Okay? But if you are not from a STEM background, then this might be new to you. And don't worry, it's kind of easy naman to work with. No? Medyo madali naman siya. It just so happened na this is one of the most important idea in analytical chem. Okay? So that's why we really have to master this. Okay? If you cannot master chemical equilibrium, then chances are mahihirapan ka um, with other chapters. Okay? So kailangan you need to master this topic. Okay? So basically, this is the heart of analytical chemistry. Okay? So yun lang. So again, for STEM students, medyo alam nyo na to. We'll just recall everything. But if you are not from a STEM background, then this is new. Okay? So don't worry, before we proceed with the calculations, of course, we'll have the concepts. Okay? So ito yung mga i-discuss natin. So for today, we'll just cover this part, and the next meeting will cover the rest. Okay? Okay. So yan. So let's begin, no? So ito this week, then ito next week na lang. So, what do we mean by equilibrium? Okay, ano ba yung root word ng equilibrium? Equal. Equal. So, parang ang pinaka-idea dito is equal. Okay? Parang yun yung root word niya. There's an equal. Okay. Ngayon, ano yung equal? Okay? So, ang equal, when you have a chemical equilibrium system, the equal there is the rate of the forward and reverse reactions. Okay? Di ba sinabi ko dalawa yung uri ng arrow in chemistry? You have your one direction arrow and your two direction arrow. Ito yung nakikita natin parate. Meaning that all the reactants will be fully converted into the product. No? And this one is the equilibrium arrow wherein you have two direction. Your reactant turning to product and vice versa. Your product turning to reactant. Okay? And yung kada direction na yan, they have their corresponding speed na. Minsan, mas malakas yung speed papuntang product. Minsan naman, mas malaki yung speed papuntang reactant. Okay? So, yun. However, if you have a chemical equilibrium, meaning that yung rate ng forward and reverse reaction are equal. So, if you look at this GIF here, so tignan nyo, may dalawang worker ants going to two different direction. Ito yung tignan nyo yung gagawin nila. Both of them will get one pebble at a time. Okay, so meaning, yung rate ng forward reaction is the same as the rate of the reverse reaction. Okay? Hindi naman necessary that the amount of the reactants and products are equal. It is not necessary. What's necessary is that in a chemical equilibrium state, there's an equal chance of your reactant turning into product and your product turning into reactant. So, siguro one way to think of an equilibrium system is when you go for vaccination. Na? So, di ba, kunwari, you go to a vaccination booth. Okay? So, ito yung medtech. Okay? Tapos yan yung plexiglass. Tapos dito ka nakaupo, right? So, the time you get vaccinated, syempre aalis ka. Di ba you will be automatically replaced by someone? Okay? Yung nasa pila. So, that in itself is an equilibrium, no? Equilibrium yan. Okay? Kasi, when you go out of your chair, merong papalit agad sa'yo. Okay? So, just like here, no? So, ang tagal naman nila maglakad. Ayan, nabasa eh. Wag na natin nantayin sila. Okay? So, parang ganun yung idea, no? When something goes to the other direction, another one directly uh, replaces them. Okay? So, tignan nyo. So, yung isa dito, papunta sa kabilang side. And ito, papalitan niya, yun na wala sa side na yan. Okay? So, kapag equal yung chances na yun, then that's an equilibrium system. Okay? So, siguro, medyo nawiweirdahan kayo, no? Yung products pala, pwede maging reactant, yes. No? Kasi nung high school, ang turo lang sa atin, yung reactant, magiging product. But in reality, may mga equilibrium system. And in fact, there are so many equilibrium systems in the body. Okay? And it is actually the reason why we don't eat always. Okay? So we only need to eat at least 2 or 3 times a day. Diba? Kasi, imagine if your body is just one direction process. Okay? Yung lahat ng kinain mo, all of them will be converted immediately to products. What do you think will happen? Edi siguro naka-IV supply na tayo, no? Okay, may tube tayo wherein the food is coming into us, no? Para tayong sasakyan, no? Wherein gasoline is constantly fed, no? Para umandar. Okay? But luckily, in human systems, there are so many equilibrium reactions that depending on the amounts of the products, the reaction can actually stop. Okay? Yan yung nangyayari sa mga metabolic pathway natin like glycolysis, Krebs cycle, electron transport chain, oxidative phosphorylation. Karamihan sa kanilang reactions ay equilibrium. So ano ba nangyayari? When you have excess products, then that will stop the reaction. Okay? So that's why you notice when you eat, di ba? After nyo kumain, you have so many reactants na and then magiging products sila. Okay? Pero when you produce so much products na, what will happen? Your body will signal you to stop eating, no? So, kumbaga nabubusog ka na. Okay? Parang yun yung idea. Okay? So you feel like you are full, but in fact, that's just your chemical equilibrium, no, in the body telling you to stop eating kasi ang dami mo ng products. Okay? You produce too much ATP na. Okay? And there's an excess of the ATP, so you need to store your carbohydrates, no, in the form of fats, no? Ganun. So, ganun ginagawa nila. Okay? So basically, that's the idea behind chemical equilibrium. No? So basically, when you say equilibrium, it is not necessary that the amount of reactant and product are equal, but what's necessary is that yung rate ng forward and reverse reaction are equal. No? There's an equal chance of forming reactants and products. No? Okay. So, yun nga, ito yung ating mga visual demonstrations. Ito naman yung sa vaccination. Pwede naman yan sa swimming pool na. Kunwari may swimming pool. Ayan. Then ito yung pool. Ayan yung pool. And then ito yung mga bata. Okay. Okay. So suppose there are 4 people here. Okay. Siyempre kapag nahulog na siya doon, may papalit agad doon, di ba? Siyempre. Okay? So parang yun yung idea ng equilibrium dito. Pag nahulog si bata to the product side, may papalit agad sa kanya. And ano mangyayari? Tapos eto, makikita niya, uy, nauubos na yung tao sa pila. Babalik uli siya. Okay? So kumbaga, there's an equal chance that you form your products or reactants na. So ito yung formation of product, yung bata pupunta sa pool. Ito yung chance ng forming reactant. Sabi niya, uy, umunti na pila. I'll go back. Okay? So, yun yung mga idea lang ng equilibrium. Okay? So, I hope nabigyan ko kayo ng konting real-life example, okay, ng equilibrium na. So, again, we have to think equilibrium because without it, we should be eating always, no? Pero since merong equilibrium, hindi na natin kailangan kumain parate. Okay? So, we can only eat at least 3 times a day. So, biglang ganun. Okay. So, chemical equilibriums are often described by an equation that shows the concentration of the product and the reactant. Okay? So, itong equilibrium system natin, it is described mathematically by this equation. This equation is called the equilibrium constant. Okay? And the equilibrium constant is the ratio of the amounts of products and the reactants. Okay? So how do we even write equilibrium constant? Okay? So for a general reaction, A plus B in equilibrium with C and D, wherein the small letters are your coefficient, ganito daw magsulat ng equilibrium constant. So for the product side, you need to multiply the molar concentrations of C and D. Okay? So molarity yung i-multiply mo. Okay? So molarity ni C times molarity ni D. Okay? So you multiply the products. And then what do you do to their coefficients? For their coefficients, you need to make them the exponent of the concentration. Okay? So, kunwari, concentration of C, and then ito yung coefficient, then you make it C raised to the coefficient. So, ganun din kay D. So, that's the concentration of D raised to the coefficient. So, ganun yung products. No? So, C raised to C, D raised to D. And then we divide that by reactant, A raised to A, B raised to B. Molarity. Molarity is mole per liter. Okay? Do not forget. Okay? So, yan. So, molarity yung ating gamit, no? Okay. So, that's K. So, that's the ratio of products and reactants. And when you see concentration, okay, that's in molarity always. By the way, whenever you see a square bracket, no, molarity yan. So, ganun kami sa keme. Minsan tinatamad na kami sulat na molarity. So, basta makita namin to, that's molarity na agad. Okay? Molarity. So, ito, this is the molarity of C, the molarity of D. Ito, molarity of C, molarity of D, molarity of A, molarity of B. Okay? So, yung mga nasa square bracket, yun yung mga molarity ng species C, D, A, B. Okay? And yung coefficient, we make them exponents. Okay? C, D, A, B. So, lahat dito minumultiply, ha? Pati divide. Baka isulat nyo ganito C plus D. Mali yan. Okay? So, we just multiply everything. Okay. Now, ano naman? What's with equilibrium constant? Okay? Siyempre, since that is an equation, meaning we will be able to get a certain value. Okay? So, when we divide the concentration of products and reactants, may value yan. Okay? So, and then tatlo yung possible value yan. So, the value is K equals 1, K greater than 1, and then K less than 1. So, these are the three possible values for your K. Now, what does it mean if your K is 1? Your K is 1. If your K is 1, meaning you achieve complete equilibrium. Okay? Medyo impossible to mangyari. But yan. So, if your K is 1, then you achieve complete equilibrium. Kumbaga, balanced lahat. No? So, look at this fish there. Okay? Ayan. So, look at the fish here. So, nung binuksan tong bridge na to, yung 5 fish sa left, 5 fish sa right, equal yung kanilang existence, no? Sa isang container. Okay? So, yan. So, kapag may pumunta doon, may pupunta doon. So, kumbaga, completely in equilibrium sila. Okay? So, that's the K equals 1. So, K equals 1 happens when your products and reactant concentration are the same. Okay? So, where is the reaction going? Di wala na. So, it is balanced na kasi. So, there is no direction for the reaction. Okay? However, if your K is greater than 1, which do you think has the greater quantity? Kapag greater than 1 yung K, sino yung mas marami? Is it the product or the reactant? What do you think? Kapag K is greater than 1, sino mas marami? The product or reactant? Ano hula niya? Product. Okay, correct yan. Okay, kapag greater than 1, edi mas malaki yung numerator. Okay? So, meaning niyan, if your K is greater than 1, we favor product formation. Okay? So, may mga ganong systems. Okay? Tignan nyo na lang yung picture dito. So, di ba earlier, they are in complete equilibrium. So, tig 5 fish on both sides na. Tig 5 fish on both sides. However, if you introduce a cat, okay, pag nakakita sila ng pusa, majority of them will go to the other side. So, if you get the K there, so this is the product, yun nasa right, and then reactant yun nasa left. So, that's 9 divided by 1. So, 9. So, it's greater than 1. Meaning nun that your product formation is more favored. Okay? Mas marami kang products kaysa sa reactant. Okay? So, kailan yan nangyayari? Kapag may pusa. Okay? Hindi, kapag may mga external stress. Okay? So, yan. Okay? So, yan. And then, ano naman mangyayari? When your K is less than 1, then probably your reactants are more in quantity, no? So, we favor reactant. Okay? So, we favor reactant formation. Okay? So, doon naman, baliktad, no? Mas maraming reactant kaysa sa products. Okay? So, to be honest with you, mas marami to. Okay? There's so many K values that are less than 1. Okay? So, kung makikita nyo sa inyong canvas, sa laboratory, okay, so sa laboratory ko siya nilagay. May table tayo doon ng K values eh. So, mas marami yung equilibrium systems that are less than 1 yung value. Bakit kaya, no? Let's try to make sense of that. Okay? Bakit kaya mas marami yung K less than 1? Okay? Let me show you. Ito yung KSP values. Ano nangyari? Anyway, so click nyo na lang yung download file. Ayan. So, kung titignan nyo, puro raised to negative something. Meaning, less than 1 sila. Okay? Look, ang daming negative. So, let's try to make sense of it, no? Kasi, bakit nga ba mas marami yung negative? Yung K less than 1. Kasi, what happens there is that your molecule dissociates. And there are so many factors when your molecule dissociates, na nandyan yung resonance of the molecule, okay? And then yung kanyang stability of the charges, no? And commonly in chemistry, mas favored talaga yung reactant kaysa sa product side, no? Commonly, no? Especially for aqueous solutions. Kasi mas stable yung reactant kaysa sa product, na. So, yun yung possible reason bakit mas marami yung K less than 1. Okay? And that is common for aqueous solutions. Okay? So, that's why if you see the pKa and the KSP value, negative yung kanilang mga exponent. Okay? So, yan. So, less than 1 sila. Okay? However, for gaseous species, no, for gases, K greater than 1 yun madalas. Okay? So, doon naman kasi sa gas, madali lang yung reaction eh. Maghihiwalay lang sila. Pero kapag yan ay aqueous, medyo mahirap yan. No? Kasi you have to consider the stability of the molecule, stability of the ion, the resonance, etc. Okay? So, yun. So, that's the equilibrium constant. No? So, the equilibrium constant is a mathematical expression that shows the ratio of the concentration of the product and reactant. And how do you write it? Basically, write the concentration of the product and divide them by the concentration of the reactant. Make your coefficients the exponent. Okay? So, kapag may coefficient, gagawing exponent. Okay? So, ganun lang siya ka-simple. Actually, dalawa yung uri ng K. Okay? Dalawa yung uri ng K. Pwedeng KP at KC. When you say KP, ito ay in terms of pressure. And when you say KC, ito ay in terms of concentration. Okay? So for aqueous species, we can only write KC. Okay? Siyempre, concentration lang meron yung mga aqueous species na. Okay? So for example, we have here H2O, the dissociation of H2O into ions. So we can only write Kc for that. Kasi ano ba yung concentration unit kapag yan ay aqueous? Eh di concentration lang. Okay? However, for gases, there are two ways of determining their concentration. One is in terms of the pressure of the gas, and the other is the concentration of the gas. Okay? Siguro you might be thinking, yung pressure, alam ko kung paano i-solve. But how about the concentration of the gas? How will I solve for that? So basically, just go back to your PV and RT, your ideal gas equation. And diba, tandaan nyo, yung molarity is mole per volume, diba, in liters. You have the mole, you have the volume. So basically, eto yan, no? Okay, so in order for you to get the molarity of the gas, that's just pressure divided by RT. Okay? So, yun. Ibig sabihin, yes, it is possible to get the molarity of the gas. No? So, that's just pressure divided by RT. Okay? So, there are two ways in determining the amounts of gases. No? Pwede in terms of pressure, pwede in terms of concentration. However, for aqueous species, the only way we can tell the amount of our species are in Kc. Okay? So let's try to make sense of what I have written here. Okay? So, for example, in H2O, ito yung product mo, di ba? So, your product, you multiply them. Okay? So, that's H plus times OH. And then for your reactant, that's H2O. However, we have a disclaimer here, no? So note that the liquids are not written in the equilibrium constant. Okay? Kapag aqueous, isusulat mo siya. Okay? So you have your aqueous here. However, if you have a liquid, you should not write it. Okay? Hindi mo siya daw isusulat. Bakit kaya? Okay? Because, ito, for general knowledge na lang din, no? Yung nagbabago yung amount, yung nagbabago yung concentration, those are the aqueous species, no? And the gas species. However, when it comes to solid and liquid, they don't change at all. Okay? Why? Let me give you an example. The molarity of water, regardless of how much water you have, is always 55.56 molar. And it doesn't change. Okay? Kasi kapag nag-convert yung iba into ion, edi onti yung volume niya. So basically, nagiging fix yung kanyang concentration. Okay? So that is true for all the liquids out there in chemistry. So ibig sabihin, basta makita kayo ng liquid, huwag nyo na isulat. Okay? Just leave it blank. Pero kapag aqueous, you have to write it. Okay? For gases naman, nagbabago yung amounts nila, of course. No? You know, the Boyle's Law, Charles Law, Gay-Lussac Law, etc. Okay? So, as you can see there, maraming pwede mangyari when it comes to gases, no? If you increase the pressure, basically, parang lumalaki yung kanyang concentration. Okay? Etc. Okay? Paano naman yung solid, no? So, the concentration, may ganun talaga. So, the concentration of solids is actually its density. Okay? Density and concentration ng solids. And you know that for solids, fixed talaga yung density niya. Okay? Regardless of the identity of the substance, fixed yung kanyang density. So, hindi talaga nagbabago yung kanyang concentration. Sa liquid naman, kung yan ay maging ion, edi umuunti lang volume yan. So, automatically it adjusts for the missing volume. So, if you compute for that, it is always 55.56 molar for water. Okay? So, ganun lang. So, ano lang isusulat mo sa equilibrium constant? Ang isusulat mo lang ay yung aqueous and yung gas lang. Pero kapag yan ay solid or liquid, wag mo na isulat. Okay? Just leave that blank. Paano naman yung Kp? So, di ba in Kc, you use a square bracket indicating their molarity. Di ba? Sa Kp naman, we use letter P to indicate pressure. Okay? So, kapag concentration, Kc, square bracket. Kapag gas, pressure, letter P lang. Okay? So, you write P on the top. Okay. And then your chemical species. And then do not forget that if you have coefficient, like in this case, it will become the exponent. Okay? Ayun, naging exponent na siya. Let's try to answer some problems. Okay? So I want you to tell me how should I write the equilibrium constants for the following reactions. Pero bago tayo pumunta dyan, basahin muna natin tong summary. Okay? So let's try to summarize everything. The concentration of reacting species in condensed phase are in molarity. Okay? So, yun yung sinasabi ko. Kapag ganyan, naka-molarity parate. Hindi pwedeng percent by mass, normality, etc. It must always be in molarity. And then for gaseous phase, okay, so depende yan. For Kp, you have your atmosphere. That's the pressure of the gas. And if you have Kc of a gas, that should be in molarity as well. Okay? Okay, and the next one, pure solid, pure liquid, and solvents do not appear in equilibrium constant. Why? Because we assume that their amounts is always constant. No? For solid, the concentration can be expressed by density. For the solvents, for the pure liquids, it is always constant talaga. Okay? And then another thing is that equilibrium constant are always dimensionless. Okay? When we say dimensionless, that just means na wala siyang unit. Okay? So, wala siyang unit. Kaya later on, pag nag-calculate tayo, hindi na tayo maglalagay ng units, na. Okay? Baka kasi isipin nyo, kailangan mag-cancel out ng units. No. Okay? Hindi talaga nagka-cancel out yung units dito. Kaya ginagawa na lang namin, we just delete the concentrations. Okay? Or the pressure units. And then lastly, in quoting the equilibrium constant, you should have their corresponding balance equation and the temperature. Okay? Ba't kailangan yung temperature? Kasi our equilibrium constant changes with temperature. Okay? Nagbabago yung equilibrium constant with temperature. For example, in the spoilage of food, meron yung corresponding K. Kapag mainit, ano nangyayari? Mabilis mapanis yung food. But if you put your food in the refrigerator, the spoilage slows down. Okay? So, yun yung pinaka-relationship ng temperature with the equilibrium constant. At higher temperature, our K becomes greater, meaning siya ay bumibilis yung reaction. Okay? It favors the product formation lalo. However, if you put it in colder environments, lumiliit yung K. Okay? So, meaning it just favors the reactant lang. Okay, that's why yung ating food, hindi agad napapanis when you place it in the refrigerator. But when you expose it outside, mabilis siya mapanis. Okay? So imagine nyo, no, may equilibrium constant pala sa pagkapanis ng food. Okay? So, ganun. Okay, so those are the things that you have to keep in mind. Okay? And then with that, so let's try to answer this. No? So ako, sasagutan ko yung letter, itong ikatlong equation. Ako na bahala dito. Tapos, kayo, tatanungin ko kayo nito and ito. Okay? Let me demonstrate to you how should I answer this one. So for the equation here, we have acetic acid and ethanol forming ethyl acetate and water. Okay? So this is an esterification reaction. So, ano gagawin ka? So I will write K. Pero ang sabi dito, Kp and Kc. So syempre, magdadalawang isip muna ako. What are the species of my how does my chemical species look like, no? Are they in the solid, liquid, gas, or aqueous phase? So you can see, aqueous to, no? And may liquid. So kapag may liquid, wag mo na pansinin. Wag mo na lang siya pansinin. Okay? So ganun yung ginagawa ko. I just don't care about the liquid. I will focus only on the solid and the aqueous and the gas phase. Okay? So look, no? Lahat sila aqueous. So meaning I can only write Kc for that. Okay? So Kc lang magagawa ko. Wala akong Kp, of course. Puro aqueous yan eh. Okay. So now, let's write the aqueous concentration, equilibrium constant, or Kc. So sa numerator, I have this, no? The ethyl acetate. Okay? So since it is aqueous, I'll express it in square bracket, no? Or in molarity. Okay? Kailangan square bracket, ha? Does it have any coefficient? Wala naman. Okay? So, meaning, wala akong magiging exponent dito ng 2, ng 3, etc. Kasi, 1 lang yan eh. Okay? So, I can just simply forget about it. Okay? So, yun yung sa numerator ko. So, that's the products. And then, for the denominator, I have two chemical species. What should I do? I must multiply their concentrations. Okay? So, that's CH3, COOH, and C2H5OH. What if po what if may coefficient dito, sir, na 5? Hindi gagawin ko yung exponent. Okay? Kunwari may 5 doon, hindi gagawin ko siyang exponent. But lucky for me, wala siyang coefficient. So, wala akong exponent. Okay? So, ganun lang na. So, that's the process of writing equilibrium constant. You check what chemical species you have. Kapag may solid liquid, burahin mo na lang. And then, if you have aqueous only, then you can write Kc. Pero if you have gases, there are two versions. You have your Kp and the Kc. Ano lang gagawin mo kapag Kp? Instead of using square bracket, you use letter P. Okay, lagyan mo lang ng P sa harap to indicate the pressure. Okay? Okay, try answering letters A and B. Type nyo na lang yung answer nyo, or kung meron kayong pang-picture dyan, picturean nyo na lang yung answer nyo. And then, send it in the chat box so that makikita natin. Okay? So, try answering A and B so that we'll see if nasundan yung paggawa ng equilibrium constant. Try nyo nga. Type nyo na lang sa chat box, ha? I'll wait for your responses. Okay? Okay, may sagot na si Louie. KC. Okay. How about the others? Tignan natin yung sagot ng iba. So again, I'd like to emphasize that this chapter is one of the most important topics in chemistry. So kailangan nyo talaga aralin siya ng malala. Okay. Sa letter B, dalawa yung sagot nyo You have KP and KC. Sa letter A, may sagot na si Louie. Okay. Yung iba naman sa letter B. Okay. Tama naman. Nakalimutan mo lang yung PKO2. Pero okay naman siya. Okay? So, yan. Hopefully, na-try nyo na rin, Okay. So, okay naman yung answers ni Louie. Okay, hopefully sa inyo, ganyan din yung nakuha niya, no? So, for letter A, again, yung liquid, just simply erase it. Okay, and as you can see, we only have aqueous species, no? So, meaning we can only write the KC. So, in the product side, I have H3O, then F minus. But for the reactant side, I have HF lang. So, that's the answer. Okay, very simple lang na. Next one. For letter B, all of them are in gas phase. And as I said, if they are in the gaseous phase, you have both Kp and Kc. So, lagay mo Kc muna. Okay? Gawin ka muna Kc. So, for Kc, in the product side, I have 2 moles of NO2. So, I write it as the concentration of NO2 squared. Okay? Naka-square, do not forget that. The concentration of NO2 squared. And then, for the reactant side, on the denominator, I have 2 species, your NO and your O2. Okay? So, you write the concentration of NO, and it has a coefficient, so you have to make it the exponent. So, NO squared. And then your O2. Okay? Kuha ba yan? Sino yung nakuha ito? Press your like button. Nakakuha kayo nito? Like button na lang. Okay? So that's good. So si Ellery, Shendel, Samantha, Richie, Aaron. Okay? That's good. And then for KP, ano gagawin mo? O yung square bracket, palitan mo lang ng letter P. Okay? Literal na letter P. Okay. So PNO2 square, PNO square, and then PO2. Okay? Yung chemical formula, medyo nilalagay ko siya sa subscript na. Parang ginagawa ko siyang subscript. Kasi, mas maganda kung letter P, yung mas malaki. Kasi baka mamaya you think of it as phosphorus. No? Yan. Kaya ginagawa ko, malaki yung letter P and then yung chemical formula maliit na. Kasi kapag same size sila, baka isipin nyo um, siya ay phosphorus. Sorry, phosphorus. Ba't kaya medyo dry yung lalamunan ko today? I don't know. Ang lamig din, no? Ang lamig recently. Okay, so ganun. Any question or clarification from the class? Or nasundan naman yung paggawa ng K? Kasi yun na yun. Okay, so I guess wala pa namang tanong for now. Okay, and hopefully clear tayo when writing K. Kasi again, sinasabi ko ngayon pa lang, this is the heart of analytical chem. Gagamitin natin siya sa titration, sa electrochemistry, sa UV-Vis, gagamitin natin siya sa chromatography. So, kailangan master nyo to. Okay? Kailangan, ito yung pinaka-master nyo talaga. And kung kayo nag-gen chem nung senior high, especially kung STEM strand kayo, napakalaking advantage. Pero kung hindi naman kayo nag STEM, okay lang. Kasi tignan niyo, madali lang naman siya, 'di ba? Okay. Madali lang gumawa ng ganito. And now, let's proceed. 'Di ba? Looking at equation letter B, you have Kc and Kp. Yung Kc and Kp mo, magkaiba yung value niyan. Of course, no? Magkaiba yung value niyan. Kasi yung isa in units of mole per liter, the other one is in APM. And you know na merong derivation na gagawin, di ba? So, magkaiba talaga sila ng value. Pero, are they related? Of course, they are related. Okay? So, the value of Kc and Kp are actually related. So, meaning, kapag binigay ko yung Kc, makukuha mo yung Kp. And vice versa. Okay? So, the equation there is this one. Okay? So, Kp equals Kc times RT delta N gas. Okay? So, the Kp and the Kc, alam nyo na yan, that's the equilibrium constants. So, may certain value yan. However, let's explain this part, no? So, R is the gas constant. Anong gas constant? 0.08206, no? Pero walang unit, kaya hindi ko nilalagay ang unit. Okay? So, walang unit kang ilalagay dyan, just the number lang. Okay? So, the R is still the gas constant we use in ideal gas equation, but without units. Okay? For temperature, ganun pa rin. Yung temp natin in Kelvin value. Okay? In Kelvin value. Hindi pa din degrees Celsius dyan. Okay? So, yung degrees Celsius, convert mo to Kelvin, and then yung K doon, wag mo na lang isulat. How about this one, the delta N gas? Okay? So, the delta N gas is actually the mole of gas in the product minus the mole of gas in the reactant. No? Suppose you have a theoretical reaction to a gas in equilibrium with B gas plus 3C gas. Let's try to determine the delta N gas for the equation. So in the reactant side, I have 2A gas, and then the product side, I have B in the gas phase, and then 3 moles of C in the gas phase. Paano ko malalaman yung delta N gas? So basically, you just count how many gas molecules you have. How many moles of gas you have in the reactant and in the product side. So for the reactant side, I only have 2 moles of gas. Siya lang naman kasing chemical species doon. So I have only 2 moles of gas. But in the product side, I have how many? Ilan meron ako sa gas? Ilan meron ako sa product side? I have how many moles of gases? 4. Correct yan. Okay, wag nyo kakalimutan yung 1 dito ha. May 1 dyan na invisible. So, I have 1 plus 3 equals 4 mole of gas. Okay? So, your delta N gas will be equal to the gas product minus the gas reactant. So, 2 siya. Okay? Again, dimensionless. Okay? So, that's how you get the delta N gas. No? So, that's the moles of gas in the product minus moles of gas in the reactant. This is my theoretical question. When is Kc equal to Kp? Tinatanong ko to sa quiz eh. Okay, this is a theoretical question. When is Kc equal to Kp? Sige, tignan ko kung hanggang saan yung kaya nyo ma-imagine. Kailan ang Kc nagiging equal sa Kp using the same equation? What do you think? Ito lumalabas to sa quiz. Binabanggit ko na siya now para hindi ko na gamitin siya sa quiz. Kasi for 2 years na anakem yung tinuturo ko. Ayan. Konti pa lang nakakasagot doon. Pero ngayon, bibigay ko na yung kasagutan sa inyo. So, when is Kc equal to Kp? Kailan sila nagiging the same? Brainstorm muna tayo. Kapag balance yung both sides. Okay? Ano meron kapag balance yung both sides? Siguro, tinutukoy ni Shindle yung amount of gas. No? So, what happens when you have equal amount of gas in both sides of the reaction? Ano nangyayari mathematically? Okay? May point yon. Pero what happens mathematically if the amount of your reactant and your product sides are equal? Ano nangyayari kaya? Kayo, siret na. Sige, ako na magsasabi. Pero tama yan, no? Tama si Shindle. Sabi niya, kapag equal daw yung amount of gas sa reactant and product, dun siya nagiging equal, no? Kc and Kp becomes equal. But mathematically, what happens? Okay? Kasi ganito, if you have equal amount of gas in the product and the reactant side, so what will be the difference? Of course, it will be 0. Okay? Ang sagot dyan, if delta N gas is equal to 0. Okay? Or meaning nun, equal yung amount ng product and the reactant side. So, kunwari, 3 minus 3, 0. 2 minus 2, 0. 1 minus 1, and 0. Okay? So, yun yung first condition. What happens mathematically? So, sabi ni algebra, anything raised to 0 is equal to 1. So, looking at our equation, Kp equals Kc RT delta N gas. If this is 0, then what will happen? Magiging ano na lang siya. Magiging 1 na lang siya. Okay? So, meaning Kc is indeed equal to Kp. Okay? So, magiging equal na lang sila. Okay? So, ganun. ito parati ko talaga to tinatanong sa Anakem. Pero this year, ibibigay ko na yung answer. Okay? Kasi onti lang nakakasagot nito correctly. Okay? So isa to sa mga medium level questions. Okay? So ganun ha. So just recall your algebra. Anything raised to 0 is 1. That's why we were able to say na kapag 0 yung delta N gas, equal yung Kc and Kp. And kailan magiging 0 yung delta N gas? If the moles of gas in the reactant and in the product side are the same. Okay, so we are actually almost done. Okay, so that's writing equilibrium constant. Okay, so again for Kc, just write the square bracket to indicate the concentration. And then for gases, you write the P or the square bracket. So it's either Kp or Kc. And again, for solids, liquids, we don't write them as we assume their amounts are always constant. And then for the Kc, it's molarity. For Kp, that's ATM. Equilibrium constants are always dimensionless kasi mahirap i-cancel out yung unit. So kami na mismo yung nagbura ng units. Okay? So ganun lang. And then if you want to get Kp from Kc, you have to use the equation here. So we're almost done. No? So we are just going to answer several questions here. And then, yan, patapos na tayo. Next meeting na to. No? Okay, so let's try this one. Okay. Patapos na tayo for this session today. Maghahanap ako ng tagabasa. Okay, kasi sabi ko sa mga classes ko, minsan nakakapagod din magsalita always. So, siguro starting next meeting, no, mag-a-assign tayo ng first reader of the day. Parang nasa simbahan na. Ano lang, babasahin nyo lang yung problem, pero ako yung magsasagot. Okay? Ayan. May gusto ba mag-volunteer, magbasa? Gagawin na natin siya. Para alam ko rin na gising pa tayo lahat. Okay? Siguro next meeting na lang na. Okay, so mag-set na lang kayo kung sino yung ating first reader, the second reader. Parang nagmimisa lang na. Tapos ako na bahala sa explanation, ako na sa homily. Sige, ako muna this time. So let me read, no? The equilibrium constant Kp for the decomposition of phosphorus pentachloride to phosphorus trichloride and molecular chlorine is found to be 105 at 250 degrees Celsius. If the equilibrium partial pressures of PCl5 and PCl3 are 0.973 atm and 0.548 atm respectively, what is the equilibrium partial pressure of Cl2 at 250 degrees Celsius? Dami sinabi. Yes. Parang gravimetry lang siya na ang dami-dami sinasabi. Okay. Basically, it just described as what the system is. Okay? So, ang first sentence, it gives us the value of Kp. Okay? And the value of Kp okay, so the value of Kp is 105 at 250 degrees Celsius. Okay? Okay, so yan. And then ano sabi? If the equilibrium partial pressure of PCl5 and PCl3 are 0.973, so that's for PCl5, 0.973, and then for PCl3, that's 0.548 atm. So what is the Cl2 daw? Okay, what's the equilibrium concentration of Cl2? Okay, ganito gagawin nyo guys. Ano gagawin? Kailangan, ano yung kailangan? Pag equilibrium problem, isulat nyo agad yung K. Okay, isulat nyo agad yung K. Kasi ganun sinasabi ko sa mga students ko, yung face-to-face pa. Sabi ko, isulat nyo yung K 1 point na yan. Tapos the rest of the problem, 10 points. F 9 points. At least may 1 point ka, di ba? Kung di mo masagutan, at least mayroong 1 point. So, ganun gagawin nyo sa problem set. Na? So, you write the K first. Okay? Okay. Ang daming sinabi, pero susulat mo K agad. Okay? So, let's write that. Na? So, since KP yung binigay, edi you write the KP. Of course. Na? And then how I will write the KP. So, the products, dalawa yung products. Yung coefficient naman nila, tigo 1 lang. So, wala tayong problem with the exponent. Okay? So, that's the pressure of PCl3 times the pressure of Cl2 all divided by the pressure of PCl5. This is the KP expression for the problem. Okay? Okay, pressure PCl3, pressure PCl2, pressure PCl5. So again, ako I highly suggest na yung letter P, lakihan nyo. Kasi kapag same size siya with the others, baka maisip nyo phosphorus siya. Okay? So, lakihan nyo yung letter P. Ano yung hinahanap? The Cl2. Okay, so we are looking for this. So, anong gagawin mo? You do some cross multiplication lang na. Cross multiply, you will get, okay, the pressure of Cl2 equal to pressure of PCl5 times the Kp divided by the pressure of PCl3. And then, plug in na lang. Okay, so the pressure of PCl5, 0.973. The Kp, 105. And the pressure of PCl3, 0.548. Ang papindot nga sa calcu. Ano yung sagot? Papindot na lang. Ano yung sagot? $186. Okay, so thank you. So it's 1.86. Okay. So, di ba mapapansin nyo, yung ating Kp, pag nagsosolve tayo using equilibrium, we don't write the units na. Pero kailangan at the end of the calculation, you should show the unit na. Kasi we are looking for the pressure. So, ATM yan. Okay, so ganun ha. So, sa problem set ninyo dito, which is ipopose ko tomorrow, ano na lang. Bale, kapag nagsosolve kayo using KP, wala talagang unit na. Pero yung final answer nyo, biglang lilitaw yung unit doon. Okay? So, ganun. Ano ba yung consensus ng scientist, no? Kasi, mahirap mag-cancel out ng units. Kaya, binubura na lang nila. Sinabi nila, dimensionless yan. Okay? But at the end of the calculation, kailangan mayroong unit na. Especially if you're solving for concentration and the pressure. Ganyan lang ka-simple na. Any question? Or okay naman? Kasi if walang question, ibibigay ko yung next problem sa inyo. Try this one. Bigyan ko kayo 3 minutes, no? Kukuha akong water. Bigyan ko kayo 3 minutes and type niyo yung final answer niyo sa chat box. By the way, ito, disclaimer. Pag malaki yung nakuha niyong value, huwag kayong magugulat. Okay lang yan. Okay? Masanay na kayo sa very big or very small values. Okay? So, I'll give you time to answer that in 3 minutes. I'll just get some water. And I'll be back. What's your answer? Ano ang nakuha niyong answer? If malaki yan, huwag kayong magugulat. 93.63 atm. Okay. Did the others get the same answer? That's very fine na. So, again, kapag malaki mo nakukuha yung value, okay lang yan. Huwag kayong magugulat. Okay? Okay, so let's answer. So, ang binigay ay Kp, which is 158 at 1,000 Kelvin. Sa ilalim po ba ng oxygen ng dagat? Ano lang naman to? Theoretical lang naman siya, kaya okay lang. Pero nung sinolve ko rin to, sabi ko, tama ba to? Tapos kinonfirm ko kung tama ba yung K ko. Tama naman. Ay sabihin, ganun talaga. Yung gulat din ako nung sinasolve ko to dati. Okay? So, yan. So, binigay yung Kp, 158. So, nung verify ko yan, correct naman. So, tas yung concentration yan talaga yung binigay. Di sabi ko, sige, okay na yan. Tanggapin ko na lang. So, let's write Kp, of course. Okay? Kapag nag-problem set kayo dito, yung Kp isusulat nyo agad. Ha? Yan. So, Kp. NO2, O2, so that's the pressure of NO square, pressure of O2, and then the pressure of NO2 square. Okay? Do not forget yung mga square, ha? So, yung NO naka-square, yung O2 hindi, yung NO2 naka-square. Okay? Ano susunod? Ang susunod ay you solve for pressure of oxygen. So since we are looking for this, we have to cross multiply the others. Huh? We have to cross multiply them. So that's the pressure of O2 equals to the pressure of NO2 square times the Kp divided by the pressure of NO square. Okay, so yung katabi ni Kp, that will be NO2 na. And then yung nasa baba will be NO. Okay, so we are going to cross multiply talaga. Ayan, so after cross multiplication, we can plug in the values. Ayan, so let's plug in the values. So for NO2, ayan, 0.4 square. For the Kp, that's 158. And then for the NO, that's 0.27. Okay, so square. Okay, for the answer, calculate tayo. Okay, so calculate. So that will be 0.4. Okay, so that will be 0.4 squared times 158 divided by 0.27 squared. 346. Kakagulat na. 346.78. Okay lang yan. Tama naman yung ating substitution. So, tanggapin na lang natin. Okay? 346.78. Asan kaya to, no? Pero tanungin natin sarili natin. Does it make sense? Okay, does the amount make sense? Looking at the K, does the amount of your product make sense, especially oxygen? Just looking at the K value. Nagme-make sense ba na malaki din yung concentration ng product? Okay? The answer is yes. Okay? Nagme-make sense naman na kapag yung product mo sobrang dami. Because remember, sabi natin, kapag K is greater than 1, it means sobrang daming products talaga. It just so happened na yung ating amount ng product ay nakalula. 346 ATM. Pero nagme-make sense siya. Why? Kasi yung KP natin ay greater than 1. So, you really have more products than the reactants. Okay? So, yan. Hindi man marami yung NO, pero marami namang O2. Okay? So, okay na yan. Tanggapin na lang natin ang ating kapalaran. Okay? So, ayan. So, that's it, no? Be careful lang sa square. Ako nga nagkamali din ako sa isa kong class nung nakaraan. yung class ko nung gabi, last week. Kalimutan ko yung square. Buti na na-point out nila. Gutom na rin kasi ako nun eh. Okay. Let's try to answer this one. Okay, so this one. Methanol is manufactured industrially by the reaction CO gas plus 2 moles H2 gas in equilibrium with methanol. The equilibrium constant Kc for the reaction is 10.5. What is the value of Kp? What is the value for Kp at this temperature? So, binigay Kc, hinahanap Kp. Madali lang yan. We have an equation for that. Okay? By the way, let me share you this technology na lang. Okay? So, actually, this technology is used in the production of methanol. It is currently being studied now to be used to convert the CO2 from the atmosphere into sugar. May ganun study eh. Kaso nakalimutan ko kung ano yung title ng paper. Okay? Basta CO2, CO, sugar. Anyway, hindi yung Calvin cycle. Basta something like that. Anyway, di ko mahanap uli yung paper. Pero nabasa ko yun na nakaraan eh. Anyway, so may isang technology daw na wherein yung CO2 or yung CO na natatrap nila from the air, they create sugars after it, no? Okay, so gumagamit sila ng energy-intensive materials, okay, and technology. So, I don't know if that will be economically feasible. Yan. So, are we doomed? Siguro. Tanggapin na lang natin ang mangyayari in the future because it seems like nothing is happening, no? Even though nagkapirmahan na ng climate, yung Paris Climate Accord, lahat-lahat na ng climate laws in-enact na, pero wala naman nangyayari. Okay. So, yun lang, medyo sad lang. Anyway, so, yan, let's hope for the best na lang. Doon sa mga umattend ng Flare, alam niyo yung mga kwento ko about climate stuff. Anyway, so let's try to answer this one. So, Kc, Kp, madali lang yan. The equation is Kp equals Kc RT delta N gas. Okay? By the way, baka malito kayo ha, baka mamaya mapagpalit niyo yung Kc and Kp. Nangyari yan sa mga student ko dati. Meron akong ilang student na napagbabaliktad nila, ginagawa na Kc, Kp. Okay? So, ano na lang isipin niya? Okay? Pressure equals MRT. So, diba ito yung nakuha natin kanina sa ideal gas equation. So, yan. Pressure MRT. Okay? M meaning concentration. Okay? So, ganun na lang isipin nyo. P is equal to MRT. Okay? So, pressure KCRT. Okay? So, para hindi nyo makalimutan. Okay? So, yan. So, ano na? You have KC, 10.5. So, that is 10.5. R is 0.08206. Temperature, it's 220 degrees Celsius. We want to convert it into Kelvin. So, anong gagawin? You add 273.15. Okay, so 273.15 i-add mo. I want to include the 0.15 parate. So, it's 493.15. And then the delta N gas. So, what do you think is the delta N gas? Okay, what do you think? -2. Okay, so let's confirm. So, in the reactant, okay, so in the reactant, I have 1 plus 2. So, that's 3 moles. But in the product side, I only have 1 mole. Okay, so remember, delta N is mole product minus mole reactant. Na? So that will be 1 minus 3. So that's -2. So that is correct. So -2. So again, walang unit ha. Okay. Yan. So we can type it in the calculator. Napindot na tayo. Asan yung mouse ko ulit? Yan. That's 10.5. Open parenthesis, 0.08206 times 493.15, close parenthesis. Hala, mali. Yan. And then raised to -2. Okay, so this is our answer. 6.41 times 10 raised to -3. Okay, did you get the same answer? 6.41 times 10 raised to -3. Okay, so ganun lang siya ka-simple. Na? Okay, so that's good. Wala namang question? Dahil patapos na tayo for the session today. Ayun, susunod yun yung malala. No? Maraming equation doon. Kaya maaga ko siya tatapusin para makapag-practice kayo. Actually, hindi pala maaga. Malapit na rin mag-time. Okay, so yun. Next meeting yung matindihang calculation dito. Okay? Let's try this last problem. Okay? So, sabi dito, consider the reaction at 395 Kelvin. Ammonium sulfide is in equilibrium with ammonia and hydrogen sulfide. The partial pressure of each gas is 0.265 atm. Calculate Kp and Kc. Ito, bibigay ko ito sa inyo. Okay? Try to answer this in 2 minutes. Mabilis lang kasi ito. And then, 3 minutes. And then, let's check kung makukuha niyo yung tamang sagot. Mag-ingat dito sa term na to, ha? Each gas. So, ibig sabihin yung mga gas species dyan, ito yung pressure niya. Okay? Ano kaya unang masasolve nyo dito? Kc o Kp? Okay, so ano kaya unang masasolve nyo dito? Kc or Kp? What do you think? Yung first na makukuha nyo. Kp, correct. Kp kasi pressure yung given. Okay? So, kapag nakuha nyo yung Kp, mamaya isosolve nyo yung Kc using the equation we used in the previous slide. Okay? Sige, try doing this in 3 minutes na. And then I'll go back to you. Type nyo na lang yung mismong answer sa chat box, ha. Then, i-verify natin kung correct. What's the answer kaya? Ano po unit ng QC? Wala rin. Wala siyang unit din. So, si KPKC no unit din. Today is ano pala? Tuesday. 2. Puro 2. Mamayang 10:22. Yan, 2 siya. 2. Hindi ko gets, ba't pa kailangan nila mag-ask ng professor para dito? Nagbabasa ako ng News 5. Kasi palindrome. Okay. So, mukha lang amazing yung palindrome, pero wala lang yan. It's not really fascinating. But anyway. Yan. So, we have an answer from Louis. Okay. So, yung iba may sagot na ba? Thumbs up na lang. Para malaman ko kung okay naman. Thumbs up na lang kapag may answer na. Nawawala yung mouse. Ayun. Okay. Let's try to answer this problem. So, sabi niyo kanina, the first thing that we will be able to solve is the KP. Of course. Bakit? Kasi gas yung binigay niya. Pressure ng gas. Okay? So, we write the KP muna. So, that will be the concentration of ammonia and the concentration of H2S. Should I write this? Hindi. Okay? So, I should not write this one. Kasi it's solid. So, I don't care about it. Ay, KP pala. Sorry. Yan. Okay, lakihan niyo yung letter P. And then, ang sabi, the pressure of each gas is 0.265. Okay? Oh, lucky for us, ang exponent niya ay 1 lang. Okay? Yan. You can just type 0.265 square. Okay? So, that's, ang dami, no? 0.070 na lang. 0.0702. Okay, ayan na lang. And then, for the KC, do not forget the proper equation is this one. Okay. And then we are solving for the KC, so we need to cross multiply everything, giving us the equation Kp over RT delta N gas. Ang correct ba yan? Ang correct naman yan. Okay? Kasi yung KC yung hinahanap eh. So I have to cross multiply this entire term. Okay? What's Kp? Adi yung nasolve mo, 0702. And then RT, so that's 0.08206. Ano yung temperature? 395. And then the delta N gas. What's the delta N gas? That's 2. Okay? Bakit naging 2, sir? Kasi nasa product side lang yung ano eh, yung gas eh. Sa reactant wala naman. So 2 moles of gas in the product, and in the reactant 0. So bale, delta N gas is 2 minus 0. Okay? And then you will be able to solve KC. To solve for KC. Yan. Okay? Kumusta na kaya mga nagfe-face-to-face classes, no? Naiinggit ako sa face-to-face eh, to be honest. Kasi 'di ba paglabas mo ng FEU, meron doon mga tusok-tusok. Ang pinaka nami-miss ko sa FEU yung ano eh, yung tawag doon, yung sa ano, bandang UST, yung ihaw. Sulit doon eh. Okay? So 0.0702 divided by 0.028 as 0.8206, 395 square. Ito yung answer. Now, did you get the same answer? Saan po nakuha yung 0.08206? Yung 0.08206, that's the gas constant. Okay? Ayan yung R, gas constant. Okay? Recall natin. Ito yan, 0.08206. Ito din yan, okay? 0.08206. Okay? So that's the gas constant. Okay? Ay, nawala ako. So, anyone who got the same answer as me? Ano kaya yun? Siguro hindi nakascore yung ano. Tatry natin yung hindi siya nakasquare. Hindi lang siya nakasquare, Louie. Pero okay naman. You just need to get the square. Hindi ko po napansin. Okay lang. Ayun, careful lang ha. Kasi ganun. So that's 6.68 times 10 raised to negative 5 na. Asan yung mouse? Ayan. So 6.68 times 10 raised to negative 5. Negative 5 na. Okay. So that's how you solve it. Again, the R is 0.08206. That is the gas constant if you use PV and RT. The temperature must always be in Kelvin value. And then yung delta N gas, that's just product minus reactant na. The moles of gas sa product and the reactant. Okay? So, with that in mind, actually, patapos na tayo. Okay? So, maraming ganitong problems sa worksheet. No? So, I'll give you the, I'll give you the opportunity to work on them. So, andito na sila lahat. No? Tapos, next meeting, mababasa nyo na yung gagawin natin. Okay. Pagbasahin nyo yung part 2, alam nyo na kung ano gagawin natin. Wow, algebra. Quadratic equation. So, next meeting yan. So, gusto ko mag-ready na kayo. But for now, ito lang tayo. So, part 1 lang tayo. So, there are so many problems here that you can try working with. Okay? So, yan. Pero hindi naman yan yung focus natin actually. Ito yung pinaka-focus ng chapter na to. Okay? Itong ice table. Kasi gagamitin nyo yan sa chapter 4 ng laboratory. Okay? Solid. Hindi papansin yung solid. Gas lang. Gas lang dapat. So, hindi dapat included si solid. Only the gaseous species ang considered. Okay? So, ayan. Okay, punta na tayo sa last part ng discussion. Yung last part ng discussion, ano lang naman to? Parang concept lang. Wala tayong isosolve. Okay? So, okay, pag may question pa, type nyo lang sa chat box, ha? Okay. While waiting, I'll continue the discussion na lang. Okay? So, operations with equilibrium constant. Okay? So, di ba, sabi natin earlier, okay? Ano sabi natin earlier? In coating, the value of equilibrium constant, sabi, the corresponding balance equation and the temperature must be written also. So, pag nagsusulat daw ng equilibrium constant, kailangan may equation. Bakit? No? Because depending on how you write the equation, pwede ma-manipulate yung equilibrium constant. So, for example, if you try to write the reverse of the equation, the equilibrium constant becomes the reciprocal of itself. So, what do we mean by that? So, for example, dito, yung N2O4, ito siya, okay? And then yung NO2 nasa product side. So, you write your equilibrium constant as NO2 square divided by N2O4. It's a product of a reactant. But what if pagpalitin mo daw sila? If you try to switch them, edi maging ganito. Yung NO2 nasa left side, yung N2O4 nasa right side. What will happen to your K? K becomes, yung N2O4 nasa numerator na siya, yung NO2 nasa baba na. So basically, na-flip lang din yung fraction natin. Okay? So that's why we said when you write the direction in the when you write the reaction in the opposite direction, it becomes the reciprocal of the original constant. Okay? So kapag pinagbaliktad mo yung equation, maging reciprocal lang siya. Okay? So ibig sabihin, kunwari, for this equation, A in equilibrium with B, of course, ang K niyan ay B over A. Let's say its value is 5. What do you think is the value of the equilibrium constant if we flip it? Ano kaya mangyayari when I flip the equation? What will be the new value of K? So Ano sa tingin nyo? 1/5, correct. Okay, so tama yan. Kasi, your new k will be the inverse of the original. So, lagay ko dito original. So, it will be 1 over original. Okay? So, magfe-flip lang siya. So, it becomes 1 over 5 or 0.2. Okay? So, that's how you deal with equilibrium constant. Kaya sinabi, kailangan may equation. Kasi depending on how you write the equation, you can change the k value. Okay? So, ganun lang. The second operation is on how you balance the equation. Okay? So, depending on your coefficients, the k value may change as well. Okay? So, let's take a look at this one. Okay? So, you still have N2O4 in equilibrium with 2 moles NO2. So, the K expression is NO2 squared divided by N2O4. What if I multiply everything by 2? What if I multiply ko lahat by 2? Edi of course, ano mangyayari? Yung exponent nila magbabago. But if you try to factor out kung ano yung minultiply mo, if you try to factor out yung minultiply mo, you will still end up with the same constant, no? Na naka-square lang. Okay? So, di ba yung exponent, pwede mo rin i-factor out. So, yun yung ginawa ko. And when I factored out yung minultiply ko doon, napansin ko that I still have my original k. But this time, it was raised to the exponent, no? To whatever number I multiplied my equation with, no? So, ibig sabihin, by multiplying your equation by 2, you get the square of the original k. What do you think will happen if I multiply it by 3? Okay, what do you think will happen if I multiply it by 3? Magiging ano siya? Okay, the new k will be the cube of my original. Okay, so magiging cube na siya. Okay, because if I write it, magiging ganito siya, no? So raised to 6. Ito, raised to 3. If I try to factor out the 3, I will have square, I will have N2O4, and then maging cube siya. And keep in mind, this is your original K. Okay? So, K1 cube. Okay? So, ganun lang siya. Okay? So, by multiplying your equation by a number, basically, you raise the constant by that number. Okay? So, kunwari, times 2, edi magiging raised to 2 yung constant. Times 3 raised to 3. Okay? So, ibig sabihin, for a theoretical equation, bibigyan ko kayo theoretical equation. Okay. So, if A in equilibrium with 3B is equal to 5, what do you think will happen if I have 2A in equilibrium with 6B? What is my K value? Okay? What's my K value kaya? So, if my original K is 5, if I multiply the equation by 2, what is my new K? What is my new K? Just to answer the question, ganito na lang. Minultiply ko to by 2, di ba? So what will happen to the K? It will be raised to what number I multiplied it with. Okay? So di ba sabi ko pag times 2, magiging square. Pag times 3, magiging cube yung original K. So meaning, if my original K is 5, if I multiply everything by 2, it becomes 25. Okay, magiging 25 siya. Bakit? Kasi 25 is 5 squared, di ba? Okay. So, kung saan mo minultiply yung equation mo, yun yung magiging exponent niya. Okay? So, 5, ayun, kapag minultiply equation by 2, the constant becomes squared. Okay? So, ganun. So, yun yung multiplication. But what if division yan? Okay? So, kapag division naman, okay, so let's say we still have the same original equation. If I divide everything by 2, what will happen? Well, same thing as multiplication. Okay? So, di ba kanina kapag multiplication, nagiging square. Okay? Pag, ano naman, kapag division, it becomes raised to a fraction exponent. And whenever you have a fractional exponent, it is the root. Okay? Nagiging square root siya. Okay? So, kung kanina, pag times 2, edi whole number yung exponent. Pero kapag dinivide mo by 2, it becomes fraction. Okay? Nagiging fraction yung exponent. Or it becomes the root. Okay? The square root. If you divide it by 3, what do you think will happen to your original k? Okay? It will become the cube root of your original k. So meaning, if my k1 here is 9, what is my k2? Okay, if my k1 is 9, what do you think is my k2? If I divide the equation by 2. Okay? O may ganito sa multiple choice sa quiz. If my k1 is 9, what do you think will be the new k if I divide the equation by 2? So the answer is the answer is pag dinivide sa 2, tandaan, magiging ano siya, raised to a fractional exponent. So it becomes 1 over 2 or square root of 9, which is 3. Okay? So ganun. So may mga ganitong items sa ating sa ating quiz. Pero onti lang na. Okay? So yan. Pag times 2, you raise it to 2. Pag divide by 2, you raise it to negative 1. You raise it to 1 half or square root, okay, of k. Kapag divide by 3, edi raise to 1 third or the cube root. And then lastly, when you combine your equilibrium constants, you actually just combine them. We multiply them lang. Okay? So for example, if yung equation na to i-combine natin with this one, so A plus 2B in equilibrium with C, and then C in equilibrium with D and E. If you try to combine the equation, the C's will cancel out, giving you the final equation. Okay? So what will happen to the K? No? So you just multiply them. Yung C nawala siya because in the first equation, it's in the numerator. And in the second equation, it is in the denominator. So kaya nawala siya dito sa final natin. We call C as our intermediate na. So that is an intermediate na, yung concentration ng C. And common to sa biochemistry. Okay? So marami kayong makikitang ganito sa biochemistry. Tawag namin doon ay coupled reactions. Okay? So yung coupled reactions in biochem, those are reactions that are accompanied by enzymes, no? So that they will have favorable K values. Okay? So yan. Pinagsasama yung dalawang reaction para yung K value favorable. Okay? So sa biochem nyo ulit ito makikita. Okay, so basically that's it na. So that's our operation with equilibrium constant. Okay, so that's it na. So if you write the equation in reverse, you get the reciprocal. If you multiply everything by 2, you get the square. By 3, you get the cube. But if you divide it by 2, you get the square root. Divided by 3, you get the cube root. And then lastly, when you combine equations, you actually multiply the equilibrium constants. Okay? So I have some problems here in the worksheet that you can work with. No? Pero hindi naman ito yung focus ng mismong chapter. So kahit chill lang kayo, okay lang. Okay? Ito yung pinaka-focus natin, yung part 2. So ako, I highly suggest try to answer all the questions muna here. May explanation na naman siya. And if something is not clear pa, you can just let me know so I can explain it to you. And then part 2, ito yung aaralin nyo maigi. Pero di-discuss ko to next meeting. Okay? So I'll discuss this next meeting kasi medyo malala siya. It requires algebra. So that pag nakita tayo next week, i-ready na ang puso, isip, at mag-algebra tayo next meeting. So ngayon, pahinga muna kaya. Okay? So I'll see you again. Okay, so that's it for our class today. I hope you learned something. And then I'll see you again next week for the continuation of chapter 3. So again, yung chapter 4, we will make it asynchronous na lang. And madali lang naman yon kasi overview pa lang siya. Okay? So I'll see you again next week. Sa mga class ko sa lab mamaya, see you uli mamaya. Okay? So later sa lab, discuss natin yung experiment before we proceed with the gravimetry again. Okay? So I'll see you again next time. Bye-bye and have a great
Thank you po.
day. Okay? Bye-bye.
Thank you po, sir.
Nawawala yung mouse. Okay? Bye-bye.